Hello, today we're going to solve the module 3 session 3 practical as a practical assignment. Here is BLAST. Here is a BLAST. Okay. Here's the sample sequence given below. Again, it's a non-redundant protein database in R using the BLAST X program. Leave all other input parameters as default. Okay, nucleotide sequence, again, it's an amino acid database by translating the nucleotide sequence into the 6 possible reading frame. Okay, here is the nucleotide sequence that must be translated to 6 possible reading frame. And here is a BLAST X, translated nucleotide to protein. And here is BAST, non-redundant. Here is this database that can be chosen, BLAST, and here is the result. This is translated proteins, and if we want to extract the sequence of protein, we have to choose AAL 71600.1 according to the question. You have to for database hit AAL 71600.1. you have to go to the sequence here and make some graphical views. Here you can see that it's from RF+1 and RF+2. Superfamily is GB 120. Here is in the 5 terminal. Here you can see it by align. Here is from in the query from the nucleotide number 268. Okay, taxonomy. It is actually human immunodeficiency virus 1. It is viruses. Graphical views, description. As the 5 end, according to graphical views, at the 5 ends, it is from RF+1. So the answer is RF+1. After which nucleotide position of the query sequence does the alignment frame change to +1? Okay, according to graphical to alignment, it is the nucleotide 268 NCBI. This and we have to extract taxation number here, copy and go to NCBI and paste it, search. Here is the protein. And here is searching translated nucleotide database using protein query. Then we have to use T+N in order to search translated nucleotide database using a protein query. Here is the protein query, and we have to exclude any model with XM or XP, that is a predicted one. BLAST, and here is the result. We can choose some nucleotides here with higher scoring, and we can download complete FASTA or GenBank or HIT or text. Then we have to download it in FASTA format. And here is the sequence of nucleotides, but it must be arranged firstly in order to be suitable here and here and here. This is a sequence. Okay, You can save it and make a local alignment of the nucleotide sequence you retrieve from 3 above with the sample sequence given above using the align 2 or more sequence option of BLAST in. And here is BLAST in. Here is BLAST in, and we choose it and using align 2 or more sequence using BLAST in. And align 2 or more sequence. Here is, we have to align the sample sequence against here is the sample sequence, copy, align this sample sequence against the extract or corresponding routines here, and paste and BLAST. And here is the result of alignment of sample sequence, which is an query, and the corresponding sequence to protein. And here is we see some deletion in sample sequence. Here is deletion, and here is deletion, some deletion in sample sequence. We see some mismatch here and here deletion, but any deletion that is behind the 268 is not an significant change, because it cannot translate it to protein. Deletion here is a mismatch. The nucleotides that can make frame shift is here, here, and here, and here. I can highlight it. They are here, but it's not significant because it's behind the 268 in the sequence. Here is this is a mismatch, but it cannot make a frame shift, but it can change the amino acid. And if the amino acid is not changing according to this mismatch, we call it an synonymous. And if the amino acid in the sequence of protein are changed, then non-synonymous. We can call it non-synonymous. Okay. And here is task 2, tyrosine transfer RNA, ligase tyrosine and copy, and then you have to go to NCPI, paste. Here is tyrosine tRNA ligase, and it is sequence length and amino acid, that's a protein. We can make it faster. Then file faster. Here is, we can choose auto faster, GI create file, and here is faster. Okay, even faster format. You can copy the sequence and get the run blast, or we can get run blast from here without any paste of any sequence, just getting run blast. We have to run blast the results, the result of tyrosine transfer RNA. Then submit a PSI-BLAST search against the UniProt KB Swiss Prot database narrowing your search organism to bacteria. Taxi 2, what is the default value of the PSI-BLAST search threshold? Here we get back to our search here. This is a benefit of choosing this show result in a new window, that we can then we can get back and choose psi, and here according to the question submit search against uniprot. Okay, we can choose uniprot spot, and we can narrowing the organism taxoid to, here is taxi to bacteria. We can choose here bacteria. Okay, bacteria taxi 2. Okay, then we go to parameters, and here is threshold filter type. Threshold is .005. Here is blast the identity column. Here we can choose it, then it can be sorted against to identity percent. The range is 78. Do you get hits to proteins other than tyrosine in the first table? In the first table, tyrosine. No, there is no other than tyrosine transfer RNA. Take a look at the taxonomy report for this search by clicking on the taxonomy tab, which organism has the lowest max alignment score for tyrosine RS. Max score, sorting it by max score, and here is, and make a taxonomy. Here is taxonomy. Here is, and when we sort the description here according to max score, and then go to taxonomy and get the last organism that have a max score. Here is the last organism, Equifax Elococcus VF5 hits. This is the last microorganism that have a max score. Okay. Then run the second iteration of psi using hits in the first table, and if you want to run second iteration, is run psi plus iteration 2. Here is run, and here is iteration 2, psi plus iteration 2, and there are ticks here with green sign. Okay, here is yellow. This is a new sequence. Let's look taxonomy, run iteration 2. Are any new sequence now added to the top table? Are any of them of tryptophan tRNA ligase? Tryptophan, yes, ligase. Here is, and save the top table in text format for future comparison. To which organism does the best scoring tryptophan T ligase hits belonging to? What is its alignment score? We have to save it in a text format. Here is, Control A, copy. Find tryptophan ligase. Tryptophan. Here is, yes, tryptophan. To which organism does the best score in tryptophan ligase hits belonging to what is its 1 score? Okay. To which organism? Here is the organism with Q9. Okay, full name. And here is tryptophan. We can search for the word tryptophan in the home. We can find tryptophan because I paste it, because I say make a search option here. Other you can use advanced find here and paste tryptophan here and get find text. Then here is the tryptophan T transfer RNA ligase, and here is the choice. Otherwise we can use the word here. It's tryptophan ligase hits belong to what organism and score. Okay, here is the organism with higher score is Q9, and we can copy it and go to MCPI and paste it here and make a search to predict the organism with higher score with tryptophan transfer RNA ligase. And here is Neisseria meningitidis MC58, also known as tryptophan transfer RNA synthesis. Another question is save the top text to which organism. Okay, do you get a tryptophan transfer RNA ligase hit to Escherichia coli? In this iteration, we can search for the name Escherichia in the save file here, paste, and we can choose option, or we can use go to and find here, paste Escherichia and find. Yes, here is an Escherichia, and we can find and okay, the question is tryptophan transfer RNA ligase hit to Escherichia coli. Okay, then here is it's tyrosine transfer RNA, and here is tyrosine. They are still tyrosine. You can use searching card, but for now I'm not interested in it. Or you can search YouTube on how using smart card search. Here is still tyrosine. Here is finishing. Escherichia coli, and beginning from the begin here. There is no tryptophan transfer RNA for Escherichia coli. And the other question is one iteration, third iteration with the hits in the top table. Do you get a hits to tryptophan of Escherichia coli? Maybe it's yes or no. According to this tutorial, you can do it yourself. If yes, what is online score and excision number of the best scoring hit? Yes, you can do that. What percent identity? I have to say goodbye for now and today.